In the last video, we hopefully set up some of the intuition for why, or I should say, what a Maclaurin series is all about. And I had said at the end of the videos that a Maclaurin series is just a special case of a Taylor series. In the case of a Maclaurin series, we're approximating this function around x is equal to 0. In a Taylor series, and we'll talk about that in a future video, you can pick an arbitrary x value, or f of x value, we should say, around which to approximate the function. But with that said, let's just focus on the Maclaurin, because to some degree it's a little bit simpler. And that by itself can lead us to some pretty profound conclusions about mathematics. And that's actually where I'm trying to get to. So let's take the Maclaurin series of some interesting functions. And I'm going to do functions where it's pretty easy to take their derivatives, and you can keep taking their derivatives over and over and over and over and over again. So let's take the Maclaurin series of cosine of x. So if f of x is equal to cosine of x, then before I even apply this formula that we somewhat derived in the last video, or at least got the intuitive for in the last video, let's take a bunch of derivatives of f of x just so that we have a good sense of it. So if we take the first derivative, derivative of cosine of x is negative sine of x. If we take the derivative of that, derivative of sine of x is cosine of x, but we have that negative there, so it's negative cosine of x. If we take the derivative of that, so this is the third derivative of cosine of x, now it's just going to be positive sine of x. And if we take the derivative of that, we get cosine of x again. So if we take the derivative of that, this is the fourth derivative. I shouldn't use this notation, but you get the idea. We'll get cosine of x again. And if you look at what we talked about in the last video, we want the function and we want its various derivatives evaluated at 0. So let's evaluate them at 0. So f of 0, cosine of 0 is 1. Cosine of 0 is 1. Whether you're talking about 0 radians or 0 degrees, it doesn't matter. Sine of 0 is 0. So this is f prime of 0 is 0. And then cosine of 0 is, once again, 1, but we have the negative out there, so it becomes negative 1. So the second derivative evaluated at 0 is negative 1. Let's take the third derivative. The third derivative evaluated at 0, well, sine of 0 is just 0. And then the fourth derivative evaluated at 0, cosine of 0 is 1. So f of prime at 0 is now equal to 1. So you see an interesting pattern here. 1, 0, negative 1, 0, 1. Then you're going to go to 0. Then you're going to go to negative 1, 0. And so if we were to apply this to find its Maclaurin representation, what would we get? So let me do my best attempt at this. So we would get our polynomial would be, so our polynomial approximation of cosine of x is going to be f of 0. F of 0 is 1. And then we have 1 plus f prime of 0 times x. But f prime of 0 is just 0. So we're not going to have this term over there. It's going to be 0 times x. I won't even take the trouble of writing it down. It would be this 0 times x. Then plus f prime prime, or its second derivative, which is negative 1. So I'll write negative, this is a negative 1 right here. This is a negative 1 times x squared over 2 factorial. Over 2 factorial, which in this case is just going to be 2. But I'll just write it down here as 2 factorial. It'll make the pattern a little bit more obvious. And then we go to the next term, the third derivative evaluated at 0. But the third derivative evaluated at 0 is just 0. So this term won't be there as well. Then you go to the fourth derivative. The fourth derivative evaluated at 0 is positive 1. So this coefficient right here is going to be a 1. And so you're going to have 1 times x to the fourth over 4 factorial. So plus x to the fourth over 4 factorial. And I think you start seeing a pattern now. You have sign switches, and you would see this if we kept going. So you can verify it for yourself if you don't believe me. So you have a positive sign, a negative sign, positive sign, and then a positive sign. And you're going to have a negative sign, so on and so forth. And this is 1 times x to the 0th power. Then you jump 2 to x to the squared, jump 2 to x to the fourth. And so if we kept that up, We had a positive sign. Now you have a negative sign. It would be x to the 6th over 6 factorial. Then you have a positive sign, x to the 8th over 8 factorial. And then you'd have a negative sign, x to the 10th over 10 factorial. And you could just keep going that way. And if you kept going with the series, this would be the polynomial representation of cosine of x. And it's frankly just kind of cool that it can be represented this way. That it's a pretty simple pattern here for a trigonometric function. Once again, it kind of tells you that all of this math is connected. And we'll see 2 or 3 videos from now. It's connected in far more profound ways than you can possibly imagine.